Hello everyone, I am A. Nasreen Banu from IT department, assistant professor from Vailtech Multitech Engineering College. The topic I am going to discuss here is transformation in computer graphics. Subject code for this is CS8092, computer graphics and multimedia. Transformation in computer graphics is nothing but we are going to discuss about how the transformation is done using geometric and coordinate transformation. There are two types of transformation, two-dimensional and three-dimensional transformation. That is, the transformation can be divided into two types. That is 2D transformation and 3D transformation. In 2D transformation, we are going to have 2D geometric transformation and 2D coordinate transformation. And in three-dimensional transformation, we are going to, it is divided into 3D geometric transformation and 3D coordinate transformation. Here we are going to see how geometric transformation is been recognized. Geometric transformation is nothing but the objects itself transform relative to stationary coordinate system. Stationary coordinate system is nothing but the geometric transformation can be transformed to stationary coordinate system, and in coordinate transformation object is stationary while the coordinate system is transformed to the relative of the object. First I will explain about what is transformation. Transformation is nothing but the fundamentals to all graphic system is the ability to stimulate the manipulation of objects in space. That is, the spatial manipulation is referred to as transformation. Here we are going to see the 2D geometric transformation, which is classified as 4 types: translation, rotation, scaling, mirror reflection along axis. That is two-dimensional transformation. The transformation in two-dimensional transformation, the transformation is restricted to 2D space, which is termed as 2D transformation. In three-dimensional transformation, the transformation that is restricted to 3D space, which is termed as 3D transformation. In 3D transformation, we will have translation, rotation and scaling. Compared to the last 4 diagrams in 2D transformation, the term translation is a transformation in which an object is displaced to a specific distance and to a specific direction. The translation used in the last 4 diagrams differs in terms that it may be two-dimensional or as well as three-dimensional, or else it can be represented as geometric or coordinate transformation. We will have 3D geometric translation, 3D geometric translation, 3D coordinate translation, 2D coordinate translation and 2D geometric translation. Now we are going to see the point representation. First we are going to see what is meant by transforms in 3D. We will have 2D column matrix, in the point representation. The point in 2D it is as represented as column matrix xy, which is referred as xy1. Now extending to 3D and z component, we will have xyz, or that is p point representation, which will indicate as px, py, pz and 1. In transforms in 3-dimensional, that is, we will have 3x3 matrix multiplication and 4x4 matrix multiplication, that is homogeneous coordinates. The translation, scaling and rotation used for 2-dimensional can be extended to 3-dimensional dimensions. In 3-dimensional, each transformation is represented by a 4x4 matrix using homogeneous coordinates, which is it is possible to represent each type of transformation in a matrix form and integrate transformation into one matrix. That is, it can apply transformations with matrices. It is 4x4 matrix, 3x3 matrix. In homogeneous coordinates can represent directions. In which direction can the matrices takes place in 2-dimensional as well as 3-dimensional transformation. Example, perspective projection also here it takes place. In homogeneous coordinates, it represents as xy, which will indicate as constant. See here, we will represent as m is equal to m11, m12, m13, m14, m21, m22, m23, m24, m31, m32, m33, m34, we will have as 4x4 matrix in the form of x form of P, that is qx, qy, qz and 1m. See, next we are going to discuss is here 3x3 matrix with 2-dimensional translation matrix x dash y dash, which will represent as x y, and tx ty, which will represent as translation matrix. Here the translation matrix can be represented as 3x3 matrix x dash y dash 1, and which will in turn as 1 0 tx 0 1 ty 0 0 1 into x comma y cross x y 1. Here in 3x3 2-dimensional translation matrix, which will represent as x dash y dash z dash is equal to x plus x y z plus tx ty tz, which will in turn as open GL, that is GL can be translated as tx ty tz, which will have x dash y dash z dash and 1. We will have 1 0 0 tx 0 1 0 ty 0 0 1 tz 0 0 0 1 cross x y z and 1, where x dash is equal to x dot 1 plus y dot 0 plus z dot 0 plus tx is equal to x plus tx, etc. See, now we are going to see about the scalings. Scaling is nothing but we have to alter object size by the scaling vector. Just we want to the object size we have to alter for the scaling factor, so that the scaling can be represented as alter object size by a scaling factor sx sy, that is x dash is equal to s dot sx, y dash is equal to y dot sy, which will represent that as x dash y dash is equal to x sx 0 0 sy xy. See the diagrammatic representation 1 comma 1 2 comma 2, which will represent as 2 comma 2 comma 4 comma 4. Here we will have 3x3 2D scaling matrix, that is x dash y dash is equal to sx 0 0 sy sy. We will term the 2D transformation, which will go for 3x3 matrix x dash y dash z dash. 2D representation is transformed to 3D representation in the form of this diagram, this equation. See here 4x4 matrix, the 3-dimensional scaling matrix, that is the 3-dimensional scaling matrix will term as 4-dimensional. It is transferred to 3-dimensional scaling matrix is transferred to 4-dimensional scaling matrix, that is x dash y dash 1 and sx 0 0 0 sy 0 0 0 1 which will be transformed to s x dash, y dash, z dash, and sx, xy, sz, and 1 cross x, y, z. Example, if you are seeing means in if you are taking sx is equal to sy is equal to 0.5, it can be scaled as 1 and 0.5. See, rotation is nothing but in 2D rotation is about a point. In 3D, rotation is about a vector which can be done through rotation about x, y, or z axis. That is, positive rotations are anti-clockwise and negative rotations are clockwise when looking down a positive axis towards the origin. That is x, y, z, which will be rotated to anti-clockwise or else clockwise. Rotation can be done about 45 degree or from here or else in anti-clockwise direction. Rotation axis can be x, y, z. That is, x is equal to r cos phi, y is equal to r sin phi, x dash is equal to r cos phi plus theta, y is equal to r sin phi plus theta. Here when we are going to compare about the origin by theta means x dash, y dash. When we are going to compute x dash, y dash, we will have x is equal to r cos phi, then y is equal to r sin phi, and x dash is equal to r cos phi plus theta, and y is equal to r sin phi plus theta, which will term as rotation by anti-clockwise or clockwise direction. When compared to 3 cross 3 when we are going to see our 3 cross 3 matrix in 2-dimensional rotation matrix, x dash, y dash is equal to cos theta sin theta, which will be termed as x dash, y dash 1, and cos theta minus sin theta, cos theta, with x axis, y axis, and 1. We will have the arbitrary axis with x dash and y dash. That's all about scaling, that is scaling, rotation, and translation in transformation, 2D transformation and 3D transformation. Thank you.